let's go. We are on page 115. We're ready to do the IVT, intermediate volume theorem for derivatives. Page 115, it says, if A and B are any 2 points in an interval on which f is differentiable, then f prime takes on every value between f prime A and f prime B, which is kind of the same thing as the IVT. Remember, the IVT was the same thing except for we didn't have the derivatives. We were talking about just the values themselves. Right? So it's the same thing as we were talking about before, right? If we had A and we had B, okay? What they're saying is that the value f prime A, which is what? It is the f prime A positive or negative here?
Negative.
Why is it negative?
Because it's going down.
Because the slope is negative, right? Because the slope is negative, right? F and f prime B, right? F prime B is going to be positive, some positive number, right?
Yeah.
So you have to have every number in between those two numbers, this guy and this guy.
Oh.
Okay.
So
It's the same thing as if you were doing just the regular IVT, right? Remember in IVT we said this? If it's continuous, it has to go through every single point between f of A and f of B, right? You can't skip any y value, right? It's kind of the same thing. So instead of this, now we're doing this. Okay? It's really just the same thing.
Okay.
All right. 3.3, rules for differentiation. So this is where the fun begins.
Wait, what?
Did you say the next chapter? This chapter is called derivatives, and the next chapter.
Okay, so 3.3, rules for differentiation.
That's what I'm saying.
Rules for differentiation says, number 1, derivative of a constant. So if I take the derivative of any constant, right, it's 0. Now if you think about this, this makes sense because remember, a constant function looks like this, correct?
Mm-hmm.
If this is 1 or 10 or whatever this may be, right? It's a constant, right?
Yes,
And the slope of this is what?
0.
0, anywhere, correct? Regardless of what x is always 0. Therefore, the derivative of any constant would make sense to be 0, correct? So think about that graphically, and you should be okay.
What is the whole D and X thing that it's doing?
So yeah, so so the function here is f. The function here is f of x is equal to c, right? It's a constant function, correct? So d of df dx, right? Remember, it's not df over dx, it's df dx, right? Which is the same thing as just taking the derivative like that. It's just a different notation. Leibniz, Newton. Leibniz, Newton. Okay? All right.
Wait, so it's F.
All right. So,
What does it mean?
rule number 3. Oh, no, rule number 2. Rule number 2 we already did, right? We did that one, right? So, x to the nth power, if I take their derivative, the n just comes to the forward, and I get that. Okay, so in other words, x to the 10th power, I take the derivative, I get what?
10x to 9.
10x to the 9th.
I have a
Pretty
question.
simple. Yes.
If you get, let's say you get, you just keep
You know,
You just keep
I
going
don't.
after that?
yeah, do you just keep going? You do? So if you have that on the homework, would you just,
So if it was like plus whatever's x, you just do this.
let's say you have x to the third and you get 3x to the second, would you keep
Okay,
going?
yeah, so that'll come up. That'll come up here soon, okay? So let's look at the constant multiple. Rule number 3. Rule number 3. Okay, so if I have a function that is some constant times the function, right? And I take the derivative of this. This is the same as, I can just pull the constant out. And it becomes that, right? See what I'm saying there? So if I have a 4x to the 6, and I take the derivative here, right? So that means that the 4, I would have already taken the 4 out, and I would take the derivative of x to the 6. The 6 comes forward, and you run like that. So it's going to be 24x to the 5th, right? We get it? The constant just comes out, all right? The constant just comes out. Right? Just like when we did the limits, remember the seed would just come forward. Same thing, same thing. Okay, example number, so rule 4 is what I think you guys were talking about. So if you have two functions, if I have function f and g, and I take the differentiation, I'm just adding the two together. In other words, if I have a function that looks like 4x to the 5th plus 2x to the 2nd, and I'm going to take the derivative of this, it's this derivative plus this derivative, right? X plus y, that's what they were saying, that's what they're saying there. So if I take the derivative of this, what do I get?
20x to the 4th.
20x to the 4th. 20x to the 4th. Plus, I take the derivative of this, I get 4x.
Wait, but Mr. R,
Uh-huh.
isn't there still the x to the 4th if you take the derivative of the x to the 4th?
Am I going to take the derivative of this again?
Yeah.
No.
So what is
Unless
the
I'm
point
told
of the
to.
derivative?
Unless it was
Because
double prime.
because
Yeah,
only
unless
the
it's double
derivative
prime,
of the
right? So
derivative
this is
is
y
the
prime.
thing.
I can go y double prime,
And then you would take
and then I would now take the derivative of this, which is
60.
80x to the 3rd. And then I would take the derivative of this, which is just...
Okay.
Yeah, that's still the
And then you
same
do
thing
it
the prime.
Huh?
It's still the same with the prime to prime.
Here to here? It's the same thing, same operation. There's different things though, right?
Where's the x go?
No, triple prime.
Where does x go?
Yeah.
Because this is x to the 1, right?
And then go
The 1 goes forward, and then I end up, so it's 1,
x to the
x
0.
to the 0. And this guy is 1, this guy is 1, so
You just get 4.
I just
So
do
is that
4.
if they continue to go?
Huh? If I have a constant here?
No, if they continue to go down like this.
If I continue to go, if I do, yeah, y triple prime, we do one more time, I get 240 x squared
Plus 0.
plus 0, this is constant.
Oh,
Mr. Johnson,
Wait, it just disappeared.
Yeah, just go
Yeah.
that way.
Because the
I can, okay, well,
the
I can,
slope at
I can go like that if you want.
Because there's no derivative to take. So
This is
then
the
it just-
constant because it's 0. We talked about
The
why
slope
it's
is 0.
constant is 0.
C
Because
prime is
it's
equal to
because
0.
It would be graphed as y is equal to 4. And there's no
so the answer still be the same as the first one.
because like
What'll be the same as the first one?
The answer with the last
Yeah, because
one.
like if you plug
your graph just got moved up forward, it didn't change the.
if you plug
slope.
Oh
something.
no, this is totally different graph.
Oh.
This is x to the 4th,
What
this is x
is
to
the
the 3rd.
derivative then?
What? The derivative is the instantaneous rate of change. It's the slope of the tangent line.
Then how can there
It
be
makes
so many
everything
different
we
ones?
did in chapter.
How can you have
Well,
the slope of a tangent line of a
okay,
tangent
so
line?
this is the slope of the tangent line, right?
Find
Yeah.
out what the
Okay,
slope
this is now the slope of this
one
thing,
and the y will be
this
y
line.
single line.
Wouldn't the slope of that line just be whatever is
No,
multiplied
it's
by
different.
A
x?
single
Different.
prime is the derivative.
How?
Within
Because remember when we did, let's say, remember what we did, we said, we found out that the
Were you there when you did the
derivative of this
like
is,
velocity? and
It's like the
stuff
derivative of
You could just keep
that.
going.
Yeah.
And your
so let's look at
velocity-
this one right here, right?
I don't know. I'm
Something
not
like
So you see the derivative, the slope of instantaneous rate of change is 0 here.
Mm-hmm.
So when he did the.
Instantaneous rate of change here is 1, right?
Yeah. Because it
See how
just
they're
becomes the
different?
other
Because
free
this
part.
guy was the y, this is the y prime.
I
But
don't
the
know.
y double prime will be different again.
Mr. On,
Okay.
could you go through the negative 16 t squared derivative of that becomes this thing becomes that thing?
Why?
She wants to know why you would take.
What's the point of the double prime?
Oh, what's the point of double prime? So, did you, are you taking physics?
No.
I am.
Okay, so,
It's just because it becomes other equations that are useful.
So if you have-
How was the test?
Yeah.
I just
displacement.
don't have enough time to be honest. I'm too
Too short.
Oh, I know this equation.
This guy, right? So this is a function of t.
Right.
If I take the derivative with regard to t, right? Just because the 2 comes forward, right? So I get, then it cancels with this, so I have just this left over. And this guy goes away, so I get v naught, right? And this is s. When I take the derivative of s, which is the rate of change of displacement, that is basically your velocity. That's how fast you're going, right? So this is velocity. So the velocity equation looks like this.
Okay.
So if I take the derivative of this, how quickly my velocity is changing, that is called
Jerk.
no, acceleration, right? Acceleration, right? So I take the derivative of this, the t goes away, and it's basically a, which is really just g, which is the gravitational constant. Right?
But one equation becomes another equation becomes another equation, and that's why it's
it just it just moves on.
Is that, how common is that though, to be asked like in the homework or on the test, like, oh, take the double prime? Is that common or?
Fairly common.
Yeah, okay.
Fairly common.
Well, how
This
do-
Well, I mean, you just have to
especially
take-
is fairly common.
You just have to take the prime twice.
Okay, so let's move on. We are now on page 121. And now here's where the fun begins. If I have a function u and a function v, and I multiply those two together, so this is a product. If I take the derivative, this is u prime v plus uv prime.
Kind of reminds me.
So I take the derivative of this, leave this
That's what
alone,
I'm saying.
then I leave this alone, then take the derivative of this.
Talking about the
see that?
u's and the
And
v's.
then you add the two.
And I had to. So if I had x squared sine x, and I take the derivative, I'm going to take the derivative of this. The derivative of this is what? Because this is u, correct?
But that would just
So I
be
take the
zero.
derivative of that. I leave this the same. Then I leave this the same. Then I take the derivative of this, which we already know is
Cosine
cosine
x.
x.
This is a lot
There you
like
go.
the
And then
sine cosine.
Oh my gosh. And then
Then
you put
what?
the.
That's it.
You just leave it at that?
what are you looking for when you're
This
doing
is the
this?
trick. So now the question, next question would be, right? If this was at this if this function, right? If I said I wanted to know what the rate of change was with x equal to pi over 2,
You just plug pi over.
I would just plug pi over 2 in here,
Oh.
and I would find out what the tangent line, the slope of the tangent line is at that
Oh,
point.
cute.
So you plug pi
That
over
way it
2
doesn't
into
sound like
that,
Correct.
and
Into
then
here.
that becomes, that's the
Yes.
slope?
Whatever I get it where it's going to be. So it's going to be what?
That's the instant rate.
Pi sine pi over 2 is what? 1. Yeah, that's correct. Plus.
Wait,
Wait, no, it's not.
And then that's 0.
Where's the unit circle?
isn't it?
Oh my gosh. Oh my
It
gosh.
goes
Sine
away.
pi over 2
Oh my
is
gosh. And
definitely
then that was
0.
pi. Oh my
No.
gosh.
Sine pi over 2 is definitely 0.
What?
Isn't it?
Pi over
Sine
2.
pi.
It's cosine sine, isn't
Cosine
it?
pi is 0.
Cosine.
That's.
Oh, that's
Pi
what.
This is your sine.
There you go, Jake. You're right.
Pi over 2. Pi.
Oh,
Right,
'cause
so it's
cosine's
cosine
first.
and then
Yeah, I
sine.
see the x value. I was like, it's definitely not.
Cosine
I
sine.
was like, what?
Oh, so he just wrote it in the reverse order.
You did it wrong.
Okay, Jula.
I did. What do you mean I did it wrong?
So it's
Sine
Wow,
pi
that's a
over
bold
2
statement, Ellie.
is 1. Cosine pi over 2 is 0.
How?
Goofy.
I don't know how to do things.
so pi is the
Mr. On
Pi
the
is
doesn't make sense.
slope.
Okay, so we're good? We're good there?
Yes.
What is pi?
Flip the page. Flip the page.
Pi is
No,
3.14.
Where
It's
is
a-
pi?
What?
No, Mr. On, stop racing.
Wait, so why? So the
So what became
so
pi?
is where
The
it
sine x or
intercepts
the
with.
cosine x?
Why is pi?
Just by
Pi?
You find pi there.
Sine
right?
pi was equal to what?
Sine pi is
0.
Cosine pi is
1.
one.
Wait, why is it negative 1?
negative
so,
1, right?
So it gives
Why
so
is it
that's
negative
showing you
one?
the things.
Don't pick
Well, I did.
Okay, so
No, they're asking what pi is.
quotient rule. What is pi? Pi is 3.14.
No, I'm saying that
What
you
was pi
found
in that?
pi from the equation, and then what do you do with that knowledge? you just are
What
like,
is
oh yes.
pi?
What is the pi?
He's just
Okay,
moving
now
That
we're
was
doing the
slope.
quotient rule.
Pi
Quotient rule.
Is that the slope of the tangent line?
Make sure you understand this.
No, but what?
Make sure that you understand. This
It's
is v squared low d. Oh, wait a minute.
What?
Wait a second, wait a
What?
second.
What are these
This is
noises you're making?
Okay. The first time is low
Okay.
d high minus high d low.
I can't even
Why
differentiate
couldn't you
between my
flip
V's
them
and my
around so they
U's.
stayed the
Yeah,
same
it's
way?
wrong. You gotta use those.
Can you do A's and B's? The U's
Low
and
d
B's.
high,
That's just
high d
asking for
low.
issue. I'm telling you.
A over b.
Thank
I need
you.
the most meat.
B
I'm not blaming
squared
you. I'm blaming them.
low d high minus
What are these
high
noises?
d low.
Low D high.
Okay,
Okay.
so go to page
It's the same as
122.
multiplication, but over
122.
denominator squared.
There's a
High.
green box
Wait,
there.
but what
Say-
if b is like something
And you're subtracting.
squared?
You squared again.
yeah, so if, yeah, v was equal to x squared, this would be x to the
Fourth.
fourth.
No, but.
So let's do it. Let's do it. Let's do it. So we have sine x over x squared.
No, but like, where did the?
Take the derivative. X to the fourth. Low d high minus high d low.
It's so much like the cosine, sine, cosine,
Okay.
cosine.
Low
thing.
d high minus high d low.
I'm just gonna remember it's the same as multiplication over the denominator squared.
That worked.
What? However it works for you.
No, because
As
no,
long as
because
it works for
multiplying
you,
is
it works for
addition.
me. Okay.
Multiplying is addition.
Now,
So subtract.
page
Just remember
123.
that.
123 says
What did I need to do?
it's the same thing we already talked about.
I think we made it through
But
enough
all
for
this
today.
saying is that it's saying that it works for negative exponents only. Also. Because all we talked about was the positive ones, right?
Mm-hmm.
So far, all we talked about was the positive ones, right? So if I had 1 over x squared and I take the derivative of this is the same as the derivative of this, which is negative 2, because this comes forward, x to the negative 3, which is the same as negative 2 x third.
Where did the negative come? Oh,
It's
you
'cause
just
it's
reversed it.
Different. You're subtracting.
Okay, so
I'm
what if you
subtracting.
did it the other way?
How I did what the other way?
What if you did it the quotient way?
The quotient way? Why would you do it the quotient way? I can do it the quotient way if you want to, but it's, I mean, really, because there's no, this is not
Okay,
a
so
function.
what if it was
This
like-
is not a function, right?
What if it was like
So
4
it's
over x
basically
squared?
0.
Well, you would just
Then you would times this by 4, right? That's it. Because it's just a constant, correct?
Don't do it that way.
But like, where does the 4 go in the next 2 steps? Wouldn't it be negative 2 over 4? Well, no, because it's not to the power of 4. But
You take it out of the thing. It's a constant.
It's the same thing, it's just a constant.
You take it out.
Now
Alright,
you,
what if there was a constant on the bottom then?
Save
let's
the
just try it your way. Let's try this with this, okay? See what happens, okay? So low squared, right? Squared over low d high. Take the derivative of this. What's the derivative of this?
0.
Oh my gosh.
Okay. Minus high d low.
And then it cancels out, so you still get. That's some crazy stuff right there. Wow.
So it
Wow.
works better.
Wow.
Works better. How does it work
Whoa,
better?
whoa.
It's the same thing.
No, because you're.
How is that better?
There are a lot
There are
more
a lot.
things to screw up here than over there.
Well, that doesn't make any sense. Where does the 4 go?
Okay, flip the page. Then we have the second, page 124. Second and higher order derivatives. This is what you guys were talking about. The y primes, the y double primes, the triple primes.
Maybe it's the number.
We want to know what we're finding.
No, you want to know.
Hang on a second.
No, me and Abby want to know.
Okay, so what was the question?
Well, I think
What are we finding? What
So
is
when
the
you
purpose of getting pi? What is pi? Like, what does the answer mean when we find this answer?
That is the slope of the
Well, it depends on what the question asks, right? Let's go to example number 7.
whatever.
Do example number 7. Let's do example number 7 together. What does it say?
Perfecto.
What does example number 7 say?
So everything we did.
It says find an equation for the
is
line,
obsolete because
tangent line to the curve, the line tangent to the curve that at point 1, 2. So I have example number 7. The point is 1 and 2. The function is
x squared plus 3 over 2x.
x squared plus 3 over 2x. So what I need to know? I have the point. I just need the
Equation.
tangent, right? The slope, right? I need the slope, right?
Yeah.
So I need to find the derivative of this. So that'll give me that. So y prime is going to be equal to 4x squared low
Oh.
d high
What does D mean?
derivative minus
Wait, where'd the 3 go?
Where'd the 3 go?
high.
Where'd
It's
the
a
three go?
constant. It's a constant. It goes away.
So
High
it's plus 0.
Yes.
d low. Right?
Wait.
Why didn't the 3 go away in this
Oh,
one?
so that's 2x.
There's no 3 to go away.
Because it's not the.
Well, it's because this is
It's not the
high.
derivative.
It's not d high. It's just high. High d low.
What it,
D low, right?
why?
Okay,
Just
so
making noises.
4x squared minus 2x squared minus 6 over 4x squared. So I get 2x squared minus 6 over 4x squared. Now, x
Why
is
did
equal
one
to
first?
1. X is equal to 1, right? So I'm going to evaluate this one. X is equal to 1, correct? X is equal to 1, so I get what? Negative 4
Why did you cancel
over
something
4.
off the top but nothing from the bottom?
Because it was 4x squared minus 2x squared.
So the y point.
So the
You
slope
literally
is
don't need
negative
it.
1. And it goes to this point, so
Oh,
the
so you
equation
just-
is,
Put it into point slope form.
that's it.
Okay.
That's so cool, Mr. Ron.
Right?
Isn't math cool?
Get it?
Yes.
Pretty neat. Pretty neat.
What did you
Pretty
do?
neat.
You skipped
So
steps.
negative
I did not
1,
skip steps.
negative
At
1
the
is
I never
the
skip
slope,
steps.
and
Yes,
then you
you
plug
do.
it into
Where? 4x squared
And
minus
it's
2x squared is 4x squared. And then I put in negative 6, and then I have the 4, right?
So you have
Then I
Oh, shoot, I have to
evaluate
go.
with x equal to 1.
You plug it
Why?
into 1, 2. Because you're given 1, 2.
Okay.
Nope.
Yeah.
Negative
2
1
minus
is your slope. 6 is the equation you did.
Then you put the 1 in.
No, 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 no,
Negative
no,
4 over
stop.
this.
No,
Wait,
look,
what?
so, no, so that's
Okay,
your slope, and
and-
you plug it into that equation, the point slope equation.
Yeah.
With 1, 2.
Then it's
No.
y
Yeah.
No, you
minus
use it
2
to make the equation.
equals negative.
You're plugging it in
And-
as the slope
Yes.
to the point slope.
Yes.
Yeah.
What?
Oh, my calculator.
Okay, we're good?
Yeah, Mr. Ron, I gotta go.
All right, we'll see ya.
Toodles.
Okay, so
I'll see if.
we're going to call today today.
Thank
No, but we didn't
goodness.
do.